Hello. Hello. In this class also, we are still looking at more examples on equations of motion. Looking at these examples. If a car starts from rest and moves uniformly with an acceleration of 10 meters per square second, calculate the distance covered after 5 seconds. If a car starts from rest, when a car starts from rest, its initial velocity u is taken as 0 meter per second. That is, since the body is starting from rest, our u will be 0 meter per second. And moves uniformly with an acceleration of 10 meter per square seconds. Our a acceleration is 10 meter per square seconds. Calculate the distance covered after 5 seconds. Distance x is question. Then time is 5 seconds. Now, from the equations of motion that we have, the three equations of motion, which of the equations of motion contains everything that we are using, that we are given, and what I'm looking for? Which of the equations of motion contains everything that I'm given here and what I'm looking for? This is u, initial velocity, a, acceleration, x, distance is what I'm looking for. Then you have t, time is 5 seconds. Now, you have a is 10 meter per square seconds. X is question. Then t is 5 seconds. Which of the equations of motion contains everything that I'm given here and what I'm looking for? Now, we have treated the equations of motion in our previous class. So, if I look at those equations of motion very carefully, it's equation 2 that goes with it. That is equation 2, that is x is equal to ut plus half at squared. It's this equation 2 that goes with it. And if you don't know the equations of motion, please feel free to check our previous lesson on equations of motion. I've written those equations of motion out and how to apply them in our previous class, so you can be free to check them out. So using equation 2 of motion, which is x equal to ut plus half at squared, then you have x is what I'm looking for. That's the question now. So you have x is equal to u is 0 times t, which is 5, plus half times t, which is 5, times a first, then times t squared, which is 5 squared. So I will have x is equal to now 5 times 0 is 0, plus this and this can cancel. I have 5 here. So you have 5, then 5 squared is 25. So my x will be equal to 0. 25 times 5, that's 225. That's 125. Then if I add together now, 0 plus 125, so I have 125 meter. So the distance traveled by the car is 125 meters. Let's look at this second example also. A train has an initial velocity of 44 meters per second. In that case, you have u, initial velocity is 44 meters per second. An acceleration of minus 4 meters per square second, that's retardation, still represented by e, is minus 4 meters per square second. Since the body, that means the body is coming to a rest. That's why you have retardation, negative acceleration, and that is minus 4 meters per square seconds. Calculate its velocity after 10 seconds. So I'm looking for v now. Final velocity is question. Then t is 10 seconds. Which of the equations of motion contains everything that I'm given here and what I'm looking for? If you check carefully, it's supposed to be equation 1. And equation 1 is v is equal to u plus at. Equation 1 is given by v is equal to u plus 80. Substituting my value now, I have v is equal to u, which is 44, plus then minus 4 times 10. So I have v is equal to 44. Plus times minus is minus, then 4 times 10 is 40. So if I subtract this from this, I have v is equal to meter per second. So my final velocity in this case is 4 meter per second. These are also examples on the application of equations of motion. So you can still stay tuned to look at more examples because this topic is very important in physics. And please feel free to subscribe to our YouTube channel at Physics with Chris and turn the notification button on. Thank you.